So yeah, I actually just found out I was giving this talk only 48 hours ago, so I put it all together yesterday. I'm sure I've missed some key details, so I'd love to talk about this after if you have any questions. As introduced, my name is Josh Weissbock, and I am talking about distributed web scraping in Python. Over the next 20-ish minutes, my intent here is to try and show you how and why to build a distributed web scraper in Python to improve your fidelity of web scraping jobs. Talk a little about myself. We'll get into what scraping is. We'll look into building an iterative approach on building a scraper and to get us to an end state where we have a distributed scraper. And we'll look at some future development and then conclude up this talk. So to start this, let's start with myself. My name is Josh Weissbock. I've been a Python user since 2008 when I was in university. Unfortunately, I'm still using Python 2.7 due to all the legacy data platforms I'm working on. And as a team of one, the rest of my team prefers new features rather than me upgrading it to Python 3. During the day, I work in the Canadian government in Victoria, BC. Right now, I'm on a year-long French course. Alors, si tu parles français, j'aimerais expliquer cette présentation-ci en français après. And then I have a second job in the National Hockey League, where I work as a data analyst, basically data science, Moneyball for a National Hockey League team. And that is really the same type of work as you would see in any other type of data science, data analysis fields, except the domain is different. And this is where I want to jump off from this talk. So my responsibilities within my NHL team is I am basically in charge of the entire data pipeline. I'm in charge of the collection of data, the storage of data, the cleaning of the data, preparing of data. And that takes up about 80% of my work. By the time that's done, I really have no effort or mental energy to work on the analysis itself. So the primary responsibility of that ends up going to the rest of my team. So because of that, I need to be on top of making sure that we have up-to-date data, that it's valid and collected as complete as possible. Every night we are running a lot of scripts, collecting a lot of data, so that way we have up-to-date information. And I need to ensure that these scripts can run with high fidelity. That means that we collect as much of the data as possible, ensuring that it's valid, and we're not missing any key information. So this talk really on the collection data is where we focus our web scraping. So we can all get on the same base. A sample scenario of a basic use case of what scraping would look like is, the intent would be to collect a lot of information from one website. This makes it easy where every web page has the exact same layout, so we know where the information is on the page, but we're trying to collect a lot of it. An example would be if you want to build a scraper to collect information from Wikipedia articles, or if you want to collect information from books off of Amazon, such as the author, the page number, the language, the ISBN, the language, the reviews, etc. So we could use Python to build a scraper to do all this. That's pretty straightforward and easy. The issue then becomes when you want to do that, not just once, but 15,000 times in a row, and trust that it's going to work. So let's start building a scraper for this use case. Python makes it very easy to request data and to start parsing it. If you ever played with any type of web scraping, you've probably done something similar. You use requests or URLlib or URLlib2 to handle the HTTP side of your requests. If you used a single script, it would have pulled the website, would have pulled the HTML out, and you would have passed it probably to some sort of parser, Beautiful Soup, LXML, and use it to actually parse the HTML to grab the specific information that you're looking for out of a website. And then ideally at that point, once you have the information, you want to give it back to the user, whether you're printing it to the screen, storing it in a CSV, saving it to a file, or storing it to a database. So like I said, doing this once, easy. Doing this 15,000 times in a row, not as easy. So let's iterate on this a bit. So the intent here is still, we want to collect 15,000 books from Amazon, or information on books. Ideally, we'd probably take this as a two-phase approach. You could create a smaller scraper, which would go through the index page of the website or through the search results of the website and generate a list of URLs that you want to parse. And then you start looping through those URLs to collect each page's worth of information. A very simple example is going to be a linear approach. You'll probably end up storing the URLs in a list, probably something in memory, and you'll just loop through it. Simple loop. Now again, that's still easy, but we're going to start running into problems when you're trying to do this 15,000 times in a row. Just by the nature of the internet, things are going to go wrong. Your internet can go down, the server can stop working, you can get 500 errors, you can get 400 errors, templates can be broken, certain pages just could be broken based on the template, based on the data that's been inputted. So probably something's going to go wrong, something's going to cause the script to crash, and you're probably going to lose all the work you've done throughout the night. So with this simple approach, even though it's easy, there's a lot of issues with it. First is going to be bot detection. If you have a single script that's hammering a single website for 15,000 pages worth of information over and over and over again, it's probably going to be labeled as a bot and probably have your IP banned. Side note, always respect robots.txt. Make sure you look at what the website wants you to be able to access and how fast you're allowed to access it. Another issue is static versus dynamic content. When I started working scraping back in 2013-14, a lot more of the internet was more static. And as we have a rise in JavaScript frameworks, Vue, React, Angular, some of the older ones, a lot more content is dynamically generated. So the simple Python libraries such as requests are no longer useful because they cannot execute the JavaScript to generate that new content. We also have issues with this simple linear approach as we have no real way of tracking our progress, what we've done so far, and checking if we've already loaded up a website. It's very costly to load up the same website twice within scraping because your biggest bottleneck is going to be the actual requesting of resources. And of course, like I said, there's so many errors that can come up along the way that you probably would not even expect, so you need some sort of way to handle these failure preventions. So we want to address these with the next iteration of our scraper. For that, I typically would have used a proxy approach. What we're doing in this scraper is we're introducing a middle layer of proxies. Our still main central computer scraper server is going to feed the requests for the resources through one of many proxies. We're going to also start throttling the requests by using random delays between requests. We're going to start rotating headers through our requests, and all these are going to help us with the bot detection side of scraping. These will make your requests look a lot more like an actual user's requesting pages rather than your script is just hammering the website. We're going to address the issue of the JavaScript by moving from requests or URL lib to something that can handle JavaScript. And my preference would be something like Selenium with a headless browser. These are a bit more costly in terms of resources used and time to actually execute it, but it'll actually allow you to run the JavaScript and allow the content to be generated so you can grab the HTML you need to parse. It also gives you a lot more tools to ensure that your content is properly loaded. We want to address the random failure issue with probably the simplest way I found. I know it's not elegant or very Pythonic, but you basically throw it in a while loop until it succeeds. You're just going to keep trying and keep trying and keep trying. That'll address a lot of things such as, like I said, if the server goes down for a few seconds, your internet goes down for a few seconds, it'll address those issues. But you still want to have some sort of catch where after so many failures, you just give up. So it's more of a try until success or just quit. And we also want to start introducing some sort of tracking of our progress. We want to know what websites we've already scraped. We want to make sure we haven't duplicated any of our efforts. And we want to start thinking of ways for us to ensure that if the script completely collapses or fails, we don't have to restart from the beginning. So that approach still has some errors. The biggest one is by adding all these different new features and layers and bot detection and that, we are slowing down our scraping time. So to give real-world anecdote, when I run a job that's about 15,000 pages, it was taking me about 26 hours to complete. That was not very efficient for needing data every single day for the team. We also have idling resources. By introducing that middle layer of proxies, only one was working at a time, so you have two sitting there. And if you're paying for resources, that's not a very good use of resources. And we still haven't addressed at this point any serious progress tracking or being able to handle any restarting the jobs from scratch without having to restart from the beginning. So these are all what led me to really be motivated to come up with some sort of distributed scraper. So the intent, like I said, was we want to address all of the previous issues that we come up with scraping so far. And I'm sure there may be a better way, but so far I found the best way is I still want to be able to retain that two-phase approach. I want my scraper to start. I can point it at the index or the search of the website. It can crawl through and generate the list of resources that I want. And then I wanted to start scraping through all the URLs that it detects on the website. So a mental model of this is something that would look like this. You have your main controller who was in charge of the phase one of the job. They're going to be the one that, it's going to be the piece of the machine that goes through the index of the search results and generates a list of URLs. And we're going to start introducing those URLs into queues that we're going to actually add to the system now. The scraper nodes are going to individually be able to pull from the working queues. They're each going to, in parallel, be able to scrape at the same time. And then they're going to feed the results from the scraping nodes back into the consumer, into a second results queue, which will then validate and store the data for final use. So we can look at that in a bit more detail. Like I said, we start with the controller. Controller is going to be the piece that is overseeing your actual generation of content and generation of unique URLs that you want to start scraping. Ideally, you'll store those in some sort of database. That way it can be persistent even if the scraping system fails. You want to use that to ensure there's no duplication of work. And you also want to use it to track where you are, so if you're mid-job and you need to restart, you don't need to start from the scratch. Once it is validated all the URLs, you can publish them to our URL queue, work queue, which then the scraping nodes can pull from the work queue and start working on the scraping jobs themselves. So when I was working with the proxy layer, I'd work with somewhere around 3 proxies in the middle. But with scraping, you can have as many as you want. And each of these are going to be using the same scraping techniques that we introduced earlier, such as the rotating headers, rotating delays between requests. It's still going to be using Slang and headless browsers to deal with the JavaScript, the try until success or just give up method. And then once it is satisfied with the results it has been able to generate, it can return its results back to the consumer, who can then move on with the saving the data. The great part of this I found is that you can actually start adding and destroying nodes midway through your progress. Adding a new node is no issue. You spin up a new node, however you choose to. We'll start pulling from the work queue. And then if something goes wrong with it, you need to destroy it because of the queue mechanisms. You can just destroy the node, and the rest of the nodes will keep working. So this will start giving us a lot more flexibility within our scraping jobs. So once the results are starting to be fed back into the results queue, the consumer will take the results out of the queue itself, validate that the data was returned properly, and start storing in a persistent method, such as a database, again, or if you want to go back to CSVs or flat files. And And then it is also in charge of making sure and coordinating with the controller which URLs have actually been completed. The controller and the consumer can be in the same machine, the same place. They don't have to be. I typically keep them in the same machine just for ease of database communication. So I've introduced queues to this model, and queues give us a lot more flexibility within managing our work within the scraping jobs, the distributed scraping jobs. We have different dispatch methods, which is ways we can ensure that all the nodes are working, whether you want every node to do the same amount of work or if you want all the nodes to be working at the same time until all the jobs are complete. You have different ACK methods to ensure that the data or the resources were actually completed, both acknowledge that the node has received it and that the consumer has received a valid response. So we can check it off the master list that the URL is complete. And then a bit more technical, typically messages use some sort of message broker. Message brokers typically only send us some sort of text string between the clients. So I found using just stringifying dictionaries to JSON and passing it between the message brokers makes this really simple and easy. Getting into more technical side of queues and message brokers, Python has a lot of different options to communicate with really easily. RabbitMQ is one I preferred and one I've used. Redis I've played a little bit. SQL and OSQL databases can be used as message brokers. And really, I'm sure there's a lot more options, but really it's depending on your project and what your environment looks like would be the best choice for you. And then Python gives us a lot of different options and APIs to actually communicate with these message brokers. Pika and Puga, very similar, very high level. I use Pika in almost all my code. I know Celery can be used in a similar fashion. I haven't used it for distributed scraping, but I use Celery for asynchronous web jobs. So there's a lot of Python APIs to ensure that the message brokers and the queues within your distributed scraping are easy to work with. So now we have a lot more advantages on this distributed web scraping system versus our proxy layer in our previous versions. The speed is, not exponentially, it's n times faster. Whereas before, when I only had one node or one layer working, we now have n times many nodes working because all the nodes are working at the same time. Again, going back to real anecdotal hours, that job that would take me 26 hours for 15,000 pages quickly drops down to 4 or 5 hours if I'm using 5 to 6 nodes. I've increased up to 10 nodes, and I'm sure I can bring it up even more, but I just haven't experimented what the max capacity is. We are no longer wasting resources, and we have no middle nodes proxies sitting there doing nothing, and that's important because you typically are paying for these. So when I'm using these are all DigitalOcean droplets that I'm spinning up. So if I have a server just sitting there doing nothing, I'm paying real money to do nothing. So I'd rather maximize my resources and see them that they're actually working. We have improved fidelity, so both on the ability to destroy nodes that are no longer working properly and introduce new ones to keep the job working effectively. I've also never, again, this is anecdotally, but I've never seen one of my nodes be detected as a bot compared to the proxy layer or compared to the linear methods. So that had a huge improvement on fidelity within my own experience. And this entire process can be done completely automatically. Again, I use DigitalOcean. I can spin up their droplets using APIs. That all can be done, again, through code automatically. So I can set a cron job, so every night everything's just spun up, starts running, collects the data, and everything's destroyed and shut down at the end. There are some disadvantages to this. There is a higher resource cost, where with the proxy layer, I typically have more nodes running, so that you have more machines running, so there's a higher cost. You don't need to have more pieces involved, but if you want the speed, you're going to be paying for more machines working at the same time. Redeployability of code is a bit of an issue. So right now, whenever I create a node, I create it from a snapshot of a DigitalOcean droplet. If I need to change the code, I have to take one machine, update the code, test that it's working, shut it down, create a snapshot, restart it up again, and then redeploy that new snapshot to all the new ones. And I'm sure that can be done, again, automatically using Git hooks. So that's more a future development than a disadvantage. And then right now, I also have in my current system an assumption of trust issue. So right now, I'm assuming that the data being entered in the work queue and the result queue is coming from only the one source that is trusted and is valid. So there is a potential security where someone could be bad somewhere in the middle and inject new information that could make things go very bad. So future development, I want to address those previous issues, like I said, address the issue of automation with the redeployability of code, address the issue of security within the assumption of trust, and I would love to have more alerts as a manager of the data to know either by text or SMS or email if a node fails to stop working or if a complete system failure, and as well I'd love to know once all the work is completed. So just to wrap it up, that was a quick run through of distributed web scraping in Python. Python makes scraping really easy to do. The issue becomes once you start looking at a large number of repeated jobs over and over and over. Just due to the nature of the internet, you need to have a lot of validation and error catching in there to ensure that the job doesn't come to a halt. And distributed web scraping can improve the fidelity and speed with a lot of these issues, although at the trade-off of a higher resource cost. So that was my quick run through distributed scraping in Python, so thank you for your time.